Hello again. We continue with lecture 16, variation of parameters. Let me point out a few things about the method compared with method of undetermined coefficients. In the method of undetermined coefficients, BT must have polynomial annihilator. In this case, you write the general form of YP, general form. Then take derivatives, plug into equation, to find coefficients. So for method of undetermined coefficients, you need polynomial annihilator. And when you're applying the method, in this case, you take derivatives. Then plug them into your equation. You get certain linear equations in terms of the coefficients, and you solve those equations to find your coefficients. Whereas the method of variation of parameters is a general method. It works for any kind, of the function bt. But the thing is, you find v prime, remember, you find vector v prime. So let's say, first, we find v prime, and then integrate. So this is the catch, if you want, or difficulty with this method. We need to integrate to find v. So in the method of undetermined coefficients, it just works for certain types of functions. And when you're working the equation, working out the method, you differentiate. But with variation of parameters, it is more general. It works for any kind of pt, but you need to integrate. And sometimes for certain functions, that integration may not be possible in terms of elementary functions. Then you may have to leave your answer in the integral form. The example I'm going to consider next, as I said, I shared lecture notes of lecture 16 in ODTÜ class. These are the Özgür Kişisel's lecture notes from last semester. And this example is the same example as in the lecture notes. But there are, I think in the lecture notes I shared, there are, I think, some mistakes. And at the end, the final answer in the notes is left in the general form. I'm going to work it out to find the particular solution. And I want to show you how each step works. It may look unnecessary, such a detailed example, but this is a class. I mean, I'm trying to teach you general methods of finding solutions, not just preparing you for certain exams. So true, in an exam, you probably will never find such a question, but I think it's an important example to understand how the variation parameters work, because for larger systems or equations of higher order, if you know how it works, you may try to you may try to write a program, for example, to find your solutions. Okay, so the example I'm going to consider is fourth order 4. So the fourth derivative of y plus 2 times the second derivative of y plus y equal to sine t. And the question is solve. Okay, now first of all, since the function bt in this case is sine t, it also fits into the method of undetermined coefficients. You can also use method of undetermined coefficients because sine t does have an annihilator, b squared plus 1. We discussed this before, but I'm going to use now the method of variation of parameters. So why do I choose the function sine t? Because as I said, in the method of variation of parameters, we need to integrate. So if you choose an arbitrary function, you may find your integration impossible in terms of elementary functions. So in order to be able to work out the integrals, I'm choosing the function sine t. You can also use, I'm going to use variation of parameters. Yourself, you may try to solve the same example using the method of undetermined coefficients and compare the two solutions and try to find the parallels. Okay. So first step is the same for both methods. First, we need to find the solutions of the corresponding homogeneous equation. So we write the corresponding homogeneous equation, fourth derivative of y plus 2 times the second derivative of y plus y equal to 0. Then we write the characteristic equation, lambda to the 4 plus 2 lambda squared plus 1 equal to 0. We can factor this out as lambda squared plus 1 squared equal to 0. So you see we are going to have double roots because we have lambda squared plus 1 squared. Now from lambda squared plus 1 equal to 0, we get lambda squared equals 1. So lambda equals plus and minus I, but both of those are a double root. So I is a double root, minus I is also a double root. So first we write the solutions for I, the complex number. Imaginary part is 1, real part is 0. So the corresponding real solutions are cosine t and sine t. And since it's a double root, for the other two solutions, we multiply the first two solutions with t. So the third solution is t cosine t, and the fourth solution is t sine t. So these are the 4 independent solutions of the homogeneous equation. For method of variation of parameters, remember, next we write the fundamental matrix. So this is going to be a 4 by 4 matrix because we have equation of order 4. So in the first row, we write the independent solutions, cosine t, sine t, t cosine t, t sine t. In the second row, we take derivatives. So derivative of cosine t is minus sine t, derivative of sine t is cosine t. For t cosine t, we need to use a product rule. Derivative of t is 1 times cosine t. T times derivative of cosine t is minus sine t. And then derivative of t sine t, again with the product rule, it is sine t plus t cosine t. Now we take the second derivatives. Derivative of minus sine t is minus cosine t. Derivative of cosine t is minus sine t. Derivative of cosine t is minus sine, but from the second term, derivative of t is 1, so you get another minus sine t. So minus 2 sine t minus t cosine t. Similarly, derivative of sine t is cosine t, but from the next term, t cosine t, when you differentiate t, you get cosine t again. So 2 cosine t minus t sine t. And the third derivative of minus cosine t is sine t. Derivative of minus sine t is minus cosine t. Derivative of minus 2 sine t minus 2 cosine t, but another minus cosine t coming from the derivative of the next term. So minus 3 cosine t plus t sine t. Derivative of 2 cosine t is minus 2 sine t, but from the next term, we pick up another minus sine t, so minus 3 sine t minus t cosine t. So this is our fundamental matrix. Now remember, to find V prime, we need to solve a fundamental matrix times V prime equal to B. And what is B? The first 3 entries are going to be 0, and the last entry is going to be sine t. In the previous example, in the example of the previous video, to find V prime, I multiplied both sides with the inverse of this matrix. But here, this is a 4 by 4 matrix, and finding the inverse may be a tedious work. So instead of finding the inverse matrix, we will use from linear algebra what is called the Cramer's rule. Okay, what is the Cramer's rule? Now, V prime, this is what I'm trying to find. It's a column vector of 4 components. So V1 prime, V2 prime, V3 prime, V4 prime. Prime here stands for the derivative. Now, to find either one, the first, second, third, or fourth. So what we do is this. To find V, say K prime, K may be 1, 2, 3, or 4, or for larger systems, it may be 5, 6, 7, 8, whatever, depending on the dimension of the system. To find Vk prime, in the matrix C, the fundamental matrix, we replace a kth column with the column B. So we take this, let's say we are trying to find V1 prime. We take the first column, and instead of the first column of the matrix, fundamental matrix, we write the column B. Okay? Let's call this matrix C sub K. So we are replacing the kth column with the column B. Then Vk prime is the determinant of this matrix Ck divided by the determinant of C. So to find a component of your unknown vector, you replace the corresponding column of your coefficient matrix with the constant column on the right side of your system, evaluate the determinant, and you divide that determinant with the determinant of the coefficient matrix. So for this method, we need to evaluate 5 determinants. First of all, we need to find 5 determinants. First of all, we need to find the determinant of the fundamental matrix. Then for the first variable, we need to find determinant of C1. For the second component, determinant of PC2. For the third component, determinant of PC3. And for the last component, determinant of PC4. I am going to find all of these determinants. Each one is going to be a 4x4 determinant. You can try doing it yourself and comparing your answer. Okay. So let's start with determinant of C. So determinant, I'm going to rewrite a lot of the same thing. It is not to be avoided. I have to do it. Then the third row. And the fourth row. Minus cosine t. All right, what I'm going to do, I'm going to make a simplification, and I'm going to make the same simplification in all of the other determinants. Remember our elementary row operations and the most important operation, adding a multiple of one row to another row. And remember that this operation doesn't change the determinant. So instead of this determinant, I'm going to change it. You see, in the first row, it starts with cosine t, and the third row, it starts with minus cosine t. So I'm going to take the first row and add it to the third row. And also, the second row starts with minus sine t, and the fourth row starts with sine t. So I'm going to take the second row and add it to the fourth row. And this will simplify the determinant somewhat. So the first two rows stay the same. Now, for the third row, I add the first row to third row. So cosine t minus cosine t, 0. Sine t minus sine t is 0. T cosine t minus 2 sine t minus t cosine t. So you see the term t cosine t cancels out. We have minus 2 sine t. And t sine t plus 2 cosine t minus t sine t. The term t sine t cancels out. We have 2 cosine t. And for the last row, I take the second row and add it to the last row. Minus sine t plus sine t is 0. Cosine t minus cosine t is 0. Minus t sine t plus t sine t cancels out. I get cosine t minus 3 cosine t, so minus 2 cosine t. And sine t minus 2 sine t. Right? Yes. And now I'm going to take the first column and expand this determinant using the first column. So the first entry is cosine t times the determinant cosine t minus t sine t plus t cosine t, 0 minus 2 sine t, 2 cosine t, 0 minus 2 cosine t, minus 2 sine t. Next, I take minus sine t, but the next one comes with a minus sign, minus sine t. Don't forget the signs. The first element starts with plus sign, and then it goes plus, minus, plus, minus, plus. So minus sine t comes with a minus sign. And then the determinant, sine t, t cosine t, t sine t, 0 minus 2 sine t, 2 cosine t, 0 minus 2 cosine t, minus 2 sine t. So cosine t times. Now, for this 3 by 3 determinant, again, I expand using the first column. So there is only one non-zero element in that column, which is cosine t. So I multiply cosine t with this 2 by 2 determinant. So let me do it now. The main diagonal, 4 sine squared t, minus the other diagonal, minus 4 cosine squared t. Then plus sine t. Again, I'm going to expand this 3 by 3 determinant using the first column. So sine t times this 2 by 2 determinant. So the main diagonal, 4 sine squared t, minus the other diagonal, minus 4 cosine squared t. So I have cosine t times cosine t is cosine squared t, and 4 sine squared t plus 4 cosine squared t is just 4, plus sine t times sine squared t. Again, 4 sine squared t plus 4 cosine squared t is 4. So this thing is, again, just 4. Because sine squared t plus cosine squared t is 1. Okay, we are going to use it later, so let me write it again. Determinant of this whole fundamental matrix is just 4. Okay. Now we need determinant of phi 1. So what is phi 1? In the first column of the fundamental matrix, we replace the first column with the column B. What is column B? Remember, the first 3 entries are 0 and the last entry is sine t. And then the other columns are the same as the fundamental matrix. Okay, now for this determinant, I'm going to use the first column. So in the first column, we have only one non-zero entry, sine t. So we are going to multiply sine t with this 3 by 3 determinant. And to simplify this 3 by 3 determinant, again, I add the first row to the third row to simplify it. I'm skipping the details, just give you the answer. This is going to be equal to minus 2 sine squared t plus 2t sine t cosine t. This determinant is going to be like this. Now, this means V1 prime, remember, determinant of C1 divided by determinant of C. So I take this determinant and divide by, remember, determinant of C we found to be 4. So this is going to be minus 1/2 sine squared t plus t over 2 sine t cosine t. And now to find the V1, we need to integrate this. The first one, to integrate the first one, we write sine squared t as 1 minus cosine 2t over 2. And for this one, for the second one, we write sine t cosine t as 1/2 sine 2t. Okay, so the first integral, minus 1 over 4, minus 1 over 4, ni derivative of 1 is t, ni derivative of cosine 2t is 1/2 sine 2t, plus I have 1 over 4. Now to integrate t times sine 2t, you need to use integration by parts. I told you in this method, we need to do some integration. So you use integration by parts. The integral of t sine 2t is minus 1/2 t cosine 2t plus 1 over 4 sine 2t. And remember, we need to add integration constant, C1. Okay, so for V2, we need to find the determinant of C2. So the first row is the same as the fundamental matrix. Now the second row we replace with B. Oh, by the way, I'm sorry. Okay, so we use the first, I made a sign mistake here. We use the first column, but sine t, we need to check the sign. Is it plus or minus? So the first one starts with plus, minus, plus, minus. So it comes with a minus sign, don't forget. So this is, this determinant is minus sine t times this 3 by 3 determinant, okay? But this result should be correct. Okay, then the third row and the third column, fourth column of C again. Now I expand using the second column. So second column, sine t, it comes with plus, minus, plus sign. So sine t times some determinant. But to simplify this determinant, again, I'm going to simplify by adding the first row to the third row. simplify and evaluate this determinant. I'm skipping some details. I'm sorry, it takes too long. You can try doing it yourself. So this determinant comes to, one moment. Okay. 2 sine t cosine t plus 2t sine squared t. And v2 prime, remember, again, you need to divide this determinant by the determinant of c, which is 4. So you get 1/2 sine t cosine t plus 1/2 t sine squared t. And now to integrate, the first one, again, you write as sine t cosine t, you write as 1/2 sine 2t. And the second one, you write sine squared as 1 minus cosine 2t over 2. And in order to integrate t times cosine 2t, again, you use integration by parts. So this integral gives you minus 3 over 16 cosine 2t plus t squared over 8 minus 1 over 8t sine 2t and plus the integration constant c2. Okay, for the third one, we need the determinant of C3. So the first two columns of the fundamental matrix is going to stay the same. For the third column, we write the column B, and the last column is going to be the same as the fundamental matrix. So we expanded using the third column. So the sign of sine t plus minus plus minus plus minus. So minus sine t times some determinant, 3 by 3 determinant. It comes from these 3 rows and the part here. And again, you use this fact. So you use the operation, adding the first row to the third row to simplify your determinant and evaluate it. This determinant is simpler. It comes to minus 2 sine t cosine t. So v3 prime, again, we need to divide this by 4. So minus 1/2 sine t cosine t. So v3 is the integral. To take the integral, again, we write sine t cosine t is 1/2 sine 2t. So v3 is 1 over 8 cosine 2t plus c3. And finally, with c4, you do the same operation. Now you take the last column of your fundamental matrix and replace it with 0, 0, 0 sine t. Apply the same operation to simplify, take the determinant. This determinant comes to minus 2 sine squared t. So v4 prime, again, we need to divide this by 4. So minus 1/2 sine squared t. We need to integrate this. And we write sine squared as 1 minus cosine 2t over 2. And when we integrate, we get 1 over 8 sine 2t minus t over 4 plus c4. So this is V4. This is V3. V2 and V1 we found as above. And finally, remember our solution is the first component of fundamental matrix times V, which is, so our solution Y, Y1 times V1 plus Y2 times V2 plus Y3 times V3 plus Y4 times V4. So with the constants, we get the solutions of the homogeneous equation. Substitute V1, V2, V3, V4, Y1, Y2, Y3, Y4. And the remaining terms, when you simplify, you get the function. Minus 1 over 4 t cosine t plus 3 over 16 sine t minus 1 over 8 t squared sine t. So this is your particular solution, and this is the solution of the homogeneous equation. Okay, I'm almost out of time. I know I skipped a lot of things. It's a long example, but as I said, it's important to understand how to do it. So please try to go over the computations yourself and send me your questions if you have any. See you next time.